interesting is gonna happen here. Maybe. So we have, this one's in slope-intercept form. So let's go ahead and graph it first because it's nice and easy. And then we'll have to put the other one into slope-intercept form before we can graph it. So y equals negative 3/4 x plus 1. Braden, which one of those is the y-intercept? The 1 or the negative 3/4? The 1. So I'm going to take the y-axis, little dot at 1, and then, Mac, what's the slope of this equation? Negative 3/4. So I'm going to go down 3, 1, 2, 3, right 4. 1, 2, 3, 4, make a dot. 1, 2, 3, 1, 2, 3, 4, make a dot. Up 3, 1, 2, 3, 1, 2, 3, 4, make a dot. 1, 2, 3, 1, 2, 3, 4, make a dot. And that, I think that's all I'm going to be able to do. I'm going to draw my line. You do lose points if you skip the line. All right, so there's the blue equation. Hopefully it crosses that other equation on one of those points. Okay, but we need to put this other equation into slope-intercept form so that we can graph this a little bit more easily. So, what is my first step in getting this equation in slope-intercept form? I have 3x plus 4y equals 12. I want it in the form y equals mx plus b. So the y needs to be completely alone. Kaysen, how am I going to get that y alone? What do I need to get away from it? I'm going to need to subtract this 3x. So I subtract the 3x from both sides, and I cannot combine the 3x and the 12 because one has an x and one's just a number. So on this left here, I'm left with 4y equals, and I'm just going to go ahead and stick the 3x to the left of the 12. It's a positive 12, so it's negative 3x plus 12. Okay, what is my final step here, Brazita?
You 4.
We have a 4 times y. How are we going to undo 4 times y? Divide by 4. So we're going to divide this by 4. We're going to divide this by 4. And we're going to divide this by 4. Those cancel out. So we have y equals negative 3/4 x plus 3. All right. Do any of you see a problem?
Yeah.
So let's see what happens. Cora, what's the y-intercept for the green equation? 3. Now, those of you who see the problem, what's the problem that you see? What is it, Kaiden?
The lines are parallel.
Or lines are, how do you know the lines are parallel? We have not graphed this thing yet.
The only thing that's different is the y-intercept.
The y-intercept is different. Maddie, what's the same?
Same slope.
They have the exact same slope. If they have the exact same slope and a different y-intercept, where do they cross?
Nowhere.
Nowhere do they cross. 1, 2, 3. 1, 2, 3, 4. These are parallel lines. And you could see it by looking at the slope. Because what's the slope on both of these? Negative 3/4 and negative 3/4. And you can see this is a flat plane, so they're never, ever, ever, ever gonna cross. If it wasn't a flat plane, that would be a different story, but they're a flat plane. So if the solution is, to this system of equations, if the solution is the point where they cross, and they never cross, what's the solution? There is no solution.
No solution.
That's a no that and got excited with it. So braided. No solution. There's no solution. They don't cross anywhere. Is that going to happen sometimes? Well, obviously, because it happened right there. They don't cross anywhere. There's no solution. Okay. So now we have two options. We have the option where they cross, and the solution is that point right there. And then we have the option where they don't cross, and there is no solution at all. Do you think there might be another option?
Yes.
What do you think the other option is, Maddie?
They could be the same exact line.
Let's find out if that's an option for us. Okay, example 2 is negative 3 halves x plus 2, and then we have 3x plus 2y equals 4. So let's graph the easy one first in blue, like we do. So what is the y-intercept of that equation, Jackson? What's the y-intercept of the blue equation? Where's it across the y-axis?
The
2. So I'm going to put a little dot at 2. And then, Demery, what's the slope of that blue equation?
3/2.
Is it? Negative 3 over 2. So it goes down 3, right 2. Down 3, right 2. Or up 3, left 2. Then we draw our line. So the solution's going to be somewhere on that line, if there is a solution. Now we know it's an option to not have a solution. All right, let's put this in slope-intercept form. What's my first step going to be? Monica, to put that into slope-intercept form.
Subtract the 3x from both.
Minus 3x from both sides. Then I'm going to do the same thing I did before and put it in front of the 4. Oops, 2. So if you keep track of your variables. 2y equals negative 3x plus 4. Okay, and now what's my final step here, lady?
Divided by 2.
Divide all the things by 2. What's 4 divided by 2?
2. Oh, they're the same thing.
They're the same line. So they're gonna look any different.
No.
But I'm still gonna graph it again.
But you can like make one purple.
It's gonna be green because I don't. Purple's not actually an option, Brayden.
Sad.
I have green, blue, black, and red. All right, so they're the same line. So if the solution is where they intersect, infinite solutions. How many points do they intersect at? Not all of them, but all of them they don't intersect at that point, right? They don't intersect at every point in the universe, but they do intersect at infinitely many points. So there's infinite solutions. All right, so now you have 3 options. They might cross at a point, they might never cross, and they might cross everywhere.
That's pretty crazy.
You have to tell me which one it is. Are there some in here that might cross at a point?
Yeah.
Maybe, maybe not. If they do cross at a point, it won't be a fraction, it'll be a whole number. So if you get them crossing at a fraction, you've done something wrong. But anyway, that's today, just a little bit more than yesterday.